Hello there, thanks for tuning in. This presentation focuses on how to configure the router on a stick or 1AM routing on the Huawei's Enterprise Network Simulation platform. So this is the architecture that we're going to be working with. We have here some devices already pre-configured. From our last presentation, we demonstrated how to configure the access port and the trunk port to isolate different hosts on a network. So at the moment, what we have is PC11 and PC33 are on the same VLAN, VLAN 10, and then PC22 and PC44 are on VLAN 20. So at the moment, what we have configured as the IP address for PC11 is 10.10.10.11. So we're using the second and third octet to denote the VLANs to which the devices belong. Right, so this is the convention that we're following. So, and then the host ID will be the ID actually in the PC, like PC11, for example. So the ID is 11. And then we're going to look at PC33 being on VLAN 10 as well. We have 10.10.10.33. And then going to PC22, we have the IP address 10.20.20, denoting that this PC belongs to VLAN 20, and then the ID of 22. And then for PC44, we have 10.20.20.44. So this is what we have at the moment for all the hosts. And then the next thing is for the switches, we have configured display VLAN, right? So what we have at the moment is for port 10 connects to the PC in VLAN 10. And then port 20 connects to the PC in VLAN 20. So what we have here is that we have VLAN 10 as a default VLAN for port 10. So it's an untagged port. We generally use the untagged port to connect to end stations. And then we have for VLAN 20, we have untagged port of Gigabit Ethernet 0/0/20 connecting to PC22, which is, of course, having the default VLAN of 20. And then we have the tagged ports, Gigabit Ethernet 001 connecting to switch 1. So what we have here is it's going to allow the tagged VLANs from VLAN 10 and VLAN 20 to go through the port 1. So we have something similar as well for switch 1, display VLAN. So that's the command you use to look at to view the VLAN configurations. So at the moment we have the VLAN 10 and 20 as well on this device. The VLAN 1 is the default VLAN for all the ports, but this is a major point of interest. So we have, as we have seen in switch 2, we have the untagged port of Gigabit Ethernet 0/0/10 belonging to VLAN 10. This one connects to PC33, like we've seen in the convention. And then for PC44, we have the untagged port 20 connecting to PC44 on VLAN 20. And then as well, the port Gigabit Ethernet 0/0/1 connects to switch 2. So the same VLANs allow past the tagged VLANs from VLAN 10 and also allow past the tagged VLANs from VLAN 20. So at the moment, if we go ahead to ping PC33, we should have communication, right, between these two computers because they belong to the same VLAN. But what happens if we try to ping PC44, for example? It's on VLAN 20, so remember the convention. You see, destination host unreachable because they cannot communicate at layer 2. So what we're going to do today is to introduce a method by which multiple devices that reside on different VLANs can be able to communicate. And one of those methods is called the router on a stick. And in some cases, it's called the 1AM routing. So here's a bit of a description here on the concept of the router on a stick. Router on a stick, or 1AM routing in some cases, is a method of inter-VLAN routing that utilizes a link between a switch and a router in order to route traffic between different VLANs. So basically what we're saying is, if we want to enable multiple devices communicate. Here we're assuming that switch 1 and switch 2 can only perform layer 2 functions. They can only tag and untag VLANs, but they cannot configure virtual interfaces. So that's the reason why we need a router in this case. So we have the router, right? So this is the game changer in the topology. So if we need PC11, for example, to communicate with PC44, the traffic needs to go to the router, and then the router as in turn will send the traffic to PC44. So it's like the gateway in this case for the different VLANs to have the communication with each other. So to do this on the eNSP platform, these are some of the steps that we need to perform. So the first thing is configure the VLAN network for switches. This has been done already. So like we've seen earlier, we described the configurations we have on switch 1 and switch 2, and as well as the IP address configuration that we have for the different hosts. The second thing is to configure a trunk link between the 1M router, which is this router, router 1, and then the downlink switch. So the downlink to the 1M router is switch 2. You can also put in switch 1, but then you need to follow the procedures as, you know, it affects the configuration that you're going to perform. So let's go ahead and start the router first of all, and then we perform step 2. So just give the router a few seconds, and then we're going to start the configuration. So before the router starts, so right now the link is on red, meaning that the router is starting, but the link isn't up yet. So let's go ahead and perform the trunk link configuration, you know, between the router and the downlink switch. So now the interface connecting the switch to the router is on gigabit Ethernet 0/0/2 on the switch 2. So what we're going to do is to allow the tagged VLANs from VLAN 10 and VLAN 20 to pass through this interface. So what that means is whatever configuration we have on gigabit Ethernet 0/0/1 will also replicate the same for port 2 on the switch. So let's go ahead and do this. We go to interface gigabit Ethernet 0/0/2, and then display this to view the current configuration. So at the moment we have no configurations on switch 2's gigabit Ethernet 0/0/2 interface. So we're going to define the port link type as trunk, right? And then port trunk allow pass, that's a command, VLAN 10 and 20. Let's deactivate this terminal monitor. Undo terminal debug, undo terminal monitor. Okay, we shouldn't have some of those prompts. So now going back to the interface, so right now we have the trunk ports configured, and then we allow pass the VLANs 10 and 20. So this configuration, we don't need to do the same on router 1. The configuration in this case is going to be a bit different. So we're going to look at that in the next few steps. So we have now configured the trunk link by specifying the uplink interface from the switch as a trunk VLAN, and then we allow pass the VLAN 10 and 20. That's the first step, right? All the VLANs we want to enable the intercommunication, we need to pass them. If we have more than two VLANs, we allow all the VLANs, specify the VLANs we want to pass, and yeah, that will be it for step 2. And then for step 3, create sub interfaces on the router for each VLAN and assign gateway IP addresses to them. So this sub interface on the router that we're creating for each VLAN is let's say something similar to, you know, configuring the trunk link on the switch, but it has a different way of working. So let's go ahead and do that. To configure a sub interface, what we do is we need to first of all go to the physical interface, but we're not going to enter the command. So first of all, type in interface gigabit Ethernet 0/0/2, and then we need to specify an ID with a dot separator. So dot and ID. So this ID generally can have the values from 1 to 4096, but just to be consistent, we can specify the ID as 10, so we can easily know in the future, okay, when we're doing the troubleshooting, okay, when we go to the ID of 10, we know that, yeah, we're working on the VLAN 10 sub interface. This is just a very good way to name the interfaces on the device. So we are going to create the sub interface for VLAN 10. So the next thing we want to do is we assign the gateway IP addresses. So the reason why we need to do this is it is through the gateways that the devices in VLAN 10 and VLAN 20 can get routed to the next network. So if there is no gateway, there is no way that these devices can route packets from one VLAN to another. So we're going to, this is the IP address that we're going to configure on VLAN 10 sub interface, which is, so we do this IP address 10.10.10.254. And then we specify the subnet mask is 24. Now remember, this is also from the subnet of VLAN 10, but in this case we use the ID of 254 to specify the gateway as we have been given in the lab. So that's the first thing. Then we do the same thing for, we create a sub interface for VLAN 20, and then we just change this ID to 20, and then we configure the IP address 10.20 in this case, .20.254, 24. Right. We're done with step 3, creating the sub interfaces and assigning gateway IP addresses. So if you have more VLANs, you need to allow the intercommunication, then you can create more sub interfaces. Then for step 4, enable the .1Q protocol on the sub interface. So we want this sub interface to terminate VLAN tags, right? So if we're sending, for example, if PC11 sends traffic to PC22, for example, it's going to send with a tag of VLAN 10 to the router. But the router needs to know what interface to place this on. So that's why we need to specify from the sub interface the .1Q VLAN ID. So that's what we're going to do in this case. So let's go ahead to the sub interface of VLAN 10, display this, and this is what we have, right? So we're going to use the command .1Q termination VID N10. That's it. Now the interface is up. So we do the same thing as well for sub interface for VLAN 20, and then this time .1Q termination VID 20. Right? This is what we have. So display this. Right. So these are the configurations that we have on the sub interface for VLAN 20 at the moment. And the next step is configure the gateways on the hosts. Now we have the IP addresses, and we also have the .1Q termination VLAN. So what we want to do now is to put a gateway IP address, to configure the gateway IP address on the host. So whenever they need to communicate with devices outside their local network, they point it directly to the router. All right, so let's go ahead, starting from PC11, let's configure the gateway IP 10.10.10.254, apply. Then we do the same for PC22, remember the naming convention, 10.20.20.254, apply. And then for PC33, let's go, 10.10.10.254, apply. And then for PC44, let's go 10.20.20.254, apply. So now we're done with step 5, right? Just to configure the gateways on the host. In practical scenarios, you wouldn't want to do this, especially when the number of hosts are a lot. So you would want to use the DHCP option. In that case, you can configure a DHCP protocol on the virtual interface, the sub interfaces you created on the router. But then that brings us to step 6. Step 6, enable our broadcast on the sub interface. Now this step is very important. Without this step, there's going to be a lot of problems you'll encounter on the network because, first of all, we're not dealing with a physical interface in this case. The physical interface on this router is actually Gigabit Ethernet 0/0/2. But when you create a sub interface, by default on the AR2220 router, It might be the same for other routers from maybe other OEMs, right? But here, when you create a sub-interface, by default, the sub-interface cannot send our broadcast messages. It cannot be able to send our broadcast messages. So what that means is, if router 1 wants to ping PC11 that is on the same network as itself, first of all, it needs to obtain the hardware address, right? So first, let's check the ARP table, display ARP. When you display ARP, you see at the moment, the router only knows the hardware address for its sub-interfaces, the sub-interfaces gigabit Ethernet 0/0/2.10 and also 4.20. So it only knows the MAC addresses for these interfaces. Now, if it wants to send ICMP message using the ping command, we want to ping 10.10.10.11, for example. Watch what's going to happen. I cannot ping PC11. Now, the reason for this is, before this ping packet can be sent, when the router is performing the encapsulation process, it'll realize that it needs to know the hardware address of PC11, but after checking the ARP cache table, it realizes that there is no mapping for PC11, and it still cannot send our broadcast because by default, our broadcast is disabled on a sub-interface. So in that case, it cannot complete this communication. But if we do the same thing from PC11, try to ping 10.10.10.254, we can ping. Why? Because now the ARP broadcast, which is in form of the ARP request message, is initiated from PC11. So we can send the ARP broadcast to obtain the hardware address. And then the router 1 will respond with a unicast ARP reply message. So we can send the ARP reply messages, which are in form of the ARP unicast message, but it cannot send the ARP broadcast. So in reality, actually, the routers cannot directly communicate with the host, except you have to manually configure the ARP mapping. And this is not very scalable because you have so many devices you need to do that for, right? So now, if we go ahead to do the same thing we're trying to do before, this is going to work, because it's already learned the MAC address of PC11 after the first communication that was initiated by PC11. So if you do the same thing, try to ping 10.10. Maybe PC22, it still cannot communicate. So this is always going to be the problem. The host will have to initiate the communication for the router to obtain the ARP mapping. That's why the step 6 is really, really important. So when you enable the ARP broadcast on the sub interface, then the router will be able to flood the ARP request messages on the VLAN where this communication is to take place. So let's go ahead and perform that step. So for the sub interface of VLAN 20, let's do that first. ARP broadcast enable. Now we're done. So interface gigabit 0/0/2.10 for VLAN 10. Let's do that. ARP broadcast enable. Right. Now in this case, we can ping any PC of our choice. So let's go ahead and ping 10.20.20.44. Right. Now the communication is possible. Not only can the router communicate with other hosts, now the hosts can also communicate with each other because they know the gateway, and the router can also initiate the ARP broadcast to other hosts when needed. So let's go ahead and from PC11 ping a PC on VLAN 20, and what we're going to get is 10.20.20.22. Right. Now we have the communication. So I guess the reason why we have a packet loss here was because of the, ARP process that is taking place. Probably slower than the router could cache the packet. Anyways, so this is all we need to configure for the router on a stick. We can ping, PCs can intercommunicate with each other. PC22 can also ping 10.10.33. That's PC33 in this case. and the communication should be possible. So this is what we have. So that's how you configure the router on a stick on the Huawei's Enterprise Network Simulation platform. This can be implemented on the Huawei routers, on the Huawei firewalls, and the configuration procedures could also be similar to other vendor products with maybe some of the differences. For example, some vendor implementations can have the R broadcast enabled by default on the sub interfaces, but these are all the steps that you need to perform to configure the router on a stick to enable the inter-VLAN routing. Thank you so much for watching, and I will see you in the next one.